Hi, this is Lori, and this is my homework for lesson number 38 in Paul McWhorter's Pico W course. This lesson and lesson 39 were a review of trigonometry that we would need to use our IMU, and it was a great lesson, and Paul gave us a little bit of homework in practicing doing sines and cosines. Well, I just thought I'd show the notes that I put together. I think some people may think I'm a little crazy, but I tend to put them into slides because I'm just very comfortable using slides. I spent my whole life doing presentations and slides, so I'm very comfortable putting things in there, and that's how I preserve my notes. And so I just thought I'd share that, and maybe some people might want to take a look at it. And it just all the details and information that Paul showed us around using a circle, a unit circle, to understand that x is the cosine of theta and y is the sine of theta, and then the tangent is the slope of this line here, which is sine of theta over cosine. And honestly, if we put this all together, we can solve a lot of problems using these very simple equations and simple mental model of how things work. Given the lecture that Paul did for us, he asked us to find the sine and cosine without using a calculator or Thani or anything. What was the sine and cosine of the following angles? And he certainly gave us enough information when we look at a unit circle and we look at those angles of 0, 90, 180, and 270, and then back to 360. The x and y points for those are really simple. So for example, here at 0 degrees or 360 degrees, this point on the unit circle is x equals 1 and y equals 0. So very simply, then the cosine of theta would be 1 and the sine of theta would be 0 at 0 degrees or 360 degrees. And then we move around the unit circle to the 90 degree mark. Well, now x is 0 and y is 1. And so again, that's our cosine and sine. Going to 180, we get minus 1 and 0. Put that in our table, and then come all the way around to 270. And now we're at x equals 0 and y equals minus 1. And so that gives us the sines and cosines that Paul asked us to do, and we didn't have to do anything but just think about this unit circle and what was the xy values for those particular angles. Pretty simple, and it's nice homework to remember our trigonometry. I made a career applying math, but I didn't use trigonometry much in my work, so I have to admit it was a good refresher to come back about this and think about it from the very first principles. So I really appreciate Paul putting that together for us. Well, I went around and did a little looking on the internet to see if there were some nice sites to look at sines and cosines, and hoping there might be some interactive tools to visualize sine and cosines. And I did find a couple of nice sites, so I'll show those coming up. And here's the first one I found at setosa.io for sine and cosine. And it's a site that's kind of devoted to explaining concepts visually. So very fun. You can look here, and it tells us all the things that Paul was teaching us, maybe in other words. So maybe if you want to look at something a little bit differently. And it sort of shows here, if I float over it, you can see it's showing the sine and cosine and the unit circle here. And it's showing the effect of changing the unit circle's radius to 2, 3, and 4. And, then we can see, the fact that the sines and cosines don't change. So if you drag this, you can move it around. So you could have also answered the homework, kind of cheating, I guess, a little bit. If you came here and you would see, let's see if I can get it right. Yeah, then we can see that the cosine and sine here at 90 degrees, and you can take this and move it around the circle and see the answers to the homework, as well as just kind of visualizing it. I mean, I think that's pretty fun. They have a little bit more here, some nice little animations that show kind of what happens as you move around here through the unit circle. And then it turns it into sort of a graph, and I think many people have seen, this function, sometimes people call that the sine wave, and again, if you click this one off, you can see the cosine as well, and you can see how they each look in comparison to each other. So there's this sort of offset between the sine and the cosine. You see that a lot. So kind of fun to look at that. And the other one I thought was pretty neat was Math is Fun site. It also has a nice site about radians, and so it tells us a little bit about the radians and how they're defined. So the angle made when the radius is wrapped around the circle. So you take the radius and you wrap it around, and that's how you get 1 radian. And so it kind of just shows you a radian is about 57 degrees, and it's a pure measure of the radius of the circle. So based on the radius of the circle, so you can kind of see how it got connected in there. Nice little animation to show that. And then showing the connection between radians and degrees with the conversion formulas that Paul walked us through. So we can see that. So anyways, you might find these useful to help visualize some of these concepts, and I certainly enjoyed looking at them and kind of putting that in my brain for future use. Well, that's my homework. Decided to publish it. I noticed not too many people put anything out there, so thought I would share my travels as I worked on the homework. Thanks for watching.